Hey guys, this is Mr. Thompson, and today this video is going to be over stoichiometry, basic stoichiometry. Now, I don't want you to feel like this is way over your head or way out there, so really pay attention during this video. Try and take the notes that I gave you in class, and let's see if we can't make this make sense, all right? The first idea that we need to get under control is how to form a molar ratio. And so we're going to want to look at chemical formulas. If you're given a chemical formula that's balanced, now if it's not balanced, you have to take care of that. But if you're given a balanced chemical formula, then those coefficients, which are the large numbers in front of each compound or element, that is the smallest whole number of moles needed in that reaction. We don't do decimals, so we'd say like 1 mole of this and 2 moles of that. Now, in order to form a molar ratio, all you do is write those numbers from the compounds. If no number is written, it's 1. But let's take a look. You know, if I'm given this formula right here, barium nitrate, lithium sulfate. So for example, if I'm given this formula, barium nitrate and lithium sulfate yields lithium nitrate and barium sulfate, which is a double reaction, which is a double replacement reaction, by the way, for those of you that are remembering from last semester. If I look, in order to form a whole number ratio, let's say that it asks for the ratio between barium nitrate and lithium sulfate. Well, barium nitrate is right here, and there's no number, so we assume it's 1. And then over here, lithium sulfate, also no number in front of it, so 1. And so the ratio is 1 to 1. But if I want to do something like lithium sulfate to lithium nitrate, well, lithium sulfate is 1, but the lithium nitrate is 2, so the ratio is 1 to 2. It's that easy. So why don't you try? On these problems right here, I'm going to go ahead and I'm going to answer them, but if you want to try them on your own, pause the video right now so that you can do these and then check your answers with what I show. So the question, what is the ratio of nitrogen gas to ammonia? Well, the number in front of the nitrogen, well, there isn't one, so it's assumed to be 1. And ammonia, NH3, right here, is this, so the ratio is 1 to 2. For the next question, what is the ratio for nitrogen gas to hydrogen gas? Well, again, 1. And hydrogen gas, 3. So 1 to 3. And then for the last one, what is the ratio of ammonia to hydrogen gas? So we start with the ammonia, that's 2. And then the hydrogen gas, which is 3. So the ratio is 2 to 3. Straightforward, simple. Okay, so now we'll get into really the tricky part of this unit, so to speak. It's basic stoichiometry calculations. I cannot stress to you enough. You've heard me say it in class. You're going to hear me say it in this video. You're going to hear me say it over and over. You need to be showing your work, A, because I won't accept it, but B, because it will make things easier. If you show your work and you do it the way I show you in these videos, in the class, it will make the calculations easier. They can be tricky and difficult if you are not showing your work. So please, 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 as I go through this, even if you don't think the work is useful, get in the habit of doing it. I promise you, you will appreciate it by the end of this unit. Okay? Let's just start with a straight mole-to-mole calculation. I want to know, using the reaction for water, how many moles of oxygen are needed to fully react with this many moles of hydrogen gas, 1.91. So we've got a reaction going on. I've got 1.91 moles of hydrogen. How many moles of oxygen do I need to react with it? So we are going to start. Here's your problem right there at the top. We're going to start by putting what is given in the problem over 1. Each time, every time, all the time. So we're going to start by putting 1.91 moles of hydrogen gas. And this is very important, guys. Moles and the hydrogen gas. Put both of those and put them over 1. In the next part, we're going to draw another fraction. Units that are on top will go to the bottom of the next fraction. Okay? So moles of hydrogen gas here, moles of hydrogen gas there. That's because they will cancel out. Where did I get this 1 and 2? Well, I actually got it from the reaction. This is my mole-to-mole ratio. For every 1 mole of oxygen in this formula, there's 2 moles of hydrogen needed. So that's exactly where I pulled that from. Put your units first, then put your numbers. Since I wanted how many moles of oxygen, I'm done. So now I just put this in the calculator. 1.91 divided by 2. And I get 0.955 moles of oxygen gas. Straightforward, simple. So why don't you try with a couple of the problems? Remember, pause the video here if you want to actually try these. Question, how many moles of oxygen gas are needed to fully react with 115 moles of ammonia. Okay, so here's your ammonia, NH3. How much oxygen is needed? So we're going to start by taking what is given and put it over 1. 115 moles of ammonia. Next, I'm going to do another fraction. I'm going to convert moles of ammonia to moles of oxygen. We're going to use that mole-to-mole ratio. Okay, 4 and 5. So I'm going to write that. Remember, moles of ammonia goes to the bottom, moles of oxygen on top. There's our ratio. Multiply it out. 115 times 5, because it's on top, divided by 4, gives you 144 moles of oxygen. For the next problem, it's going to start exactly the same way. We have 48.3 moles of nitrogen monoxide, so we put that over 1. And we're going to draw another fraction. This time, we're going from nitrogen monoxide to water. So again, we're going to do that mole-to-mole ratio, 5 water, 4 nitrogen monoxide. And so 5 over 4, those units would cancel out. We're left with 60.4 moles of water. Now, we can take it up to another level. What if it's in grams? What if we start with grams? No problem. We're just going to add another step to convert it to moles in the same calculation. So take this example problem. Again, reaction for water. How many moles of oxygen gas are needed to fully react with 21.7 grams of hydrogen? All right, start with what we're given. Put it over 1. 21.7 grams of hydrogen. We're going to convert grams into moles. 1 mole of H2, there's 2.1016 grams of hydrogen. Comes from the periodic table. Units are going to cancel, but we're not where we want to be. I wanted to know moles of oxygen, not moles of hydrogen. So I'm going to do another fraction, and this time we're going to use that mole-to-mole ratio. 1 mole of O2, 2 moles of hydrogen. That comes straight from this formula right here again. Units cancel. Now look, now I'm at moles of oxygen. That tells me I'm finished. No more steps. Plug it into the calculator. What's on top multiplies. What's on bottom divides. And you get 5.38 moles of oxygen. Nope. Asked to find grams instead. So we look at the problem, change just a little bit now. How many grams of oxygen are needed to react with 18.7 moles of hydrogen? Okay, take what we're given. Put it over 1. 18.7 moles of hydrogen. We're already at moles, so we can do our mole-to-mole ratio. We do not have to convert to grams yet. So, moles of hydrogen on bottom, moles of oxygen on top. Units cancel, but I'm not finished with the problem. The problem asks me grams of oxygen. Grams of oxygen. I'm at moles, so I need to do one more step. I need to convert moles into grams. Moles on top, moles on bottom, they cancel out. Okay, this is O2, so there's 2 oxygen, 31.998 grams. Multiply it out, top times top, divided by what's on bottom, and you get 299 grams of oxygen gas. Now I know what you're thinking. You might be starting to panic. What if the problem wants you to go from grams to grams? Just add another step. It's just one more step. Again, same formula, water. How many grams of water are produced? If 28.9 grams of oxygen are used. Okay. So we start by taking what we're given, put it over 1. Grams of oxygen. We need to go from grams to moles. You cannot do the mole-to-mole ratio if you're not in moles. So we've got to convert to moles. Okay, units cancel. Got moles of oxygen. Now I want to go to moles of water. Okay, no problem. 1 oxygen, 2 water. There you go. Units cancel. Keep going now. We got moles of water. I want grams of water. So, moles goes on bottom. Mole on top, mole on bottom. They cancel. This right here, you get this. 2 hydrogen plus 1 oxygen. Multiply it out. Top numbers get multiplied, so 28.9 times 2 times 18.015 divided by 31.998, and you get 33.6 grams of water. So it's all the same work, it's just how many steps do I need to do. And if you do this method, if you show all of this work, your units cancel, it lets you know when you're finished. I wanted grams of water. How many grams of water? Okay. Once I get to grams of water, I'm done. So why don't you give these a shot? Why don't you try these problems right here? Remember, pause the video if you want to attempt it. Question, how many grams of hydrofluoric acid? We got grams of hydrofluoric. We start with grams of fluorine. All right? Start by putting what you're given over 1. Going to convert to moles first. Got to do moles first. So we're going to go forward. Okay? 1 mole of fluorine gas, F2. We got that many grams from the periodic table. Okay? Mole to mole ratio, given in our formula right here. 2 fluorine gas, 4 hydrofluoric acid. Okay? That's where those numbers come from. And then convert moles of hydrofluoric acid. And then we want to convert moles of hydrofluoric acid into grams. Multiply it out, numbers on top, divided by numbers on bottom, and you get 41.9 grams. The next two are going to work exactly the same. We start out with grams, go to moles, do the mole to mole ratio, go back to grams. So the second one, 120 grams of hydrofluoric acid are produced. It'll look like this. How many grams of fluorine gas needed to produce 100 grams of hydrofluoric acid? There you go.